Hello everyone. In this video, we are going to revise the chapter Areas Related to Circles from the Basics, which belongs to class 10 CBSE. At the end of the video, I have given some sample problems to practice. I have already uploaded all those problems individually. I will be giving the link over here in the description. Please practice and check the answers to all those are very important problems. So let's start this video from the very basics. First, let's see the concept overview of a circle. First, we'll take a circle. Generally, how can we draw a circle? We need one center point as well as a radius. So here I'll mark the center as O. And what is radius from the center point to any point on the circumference of a circle as radius. So here I can mark this point as A. Now I can even extend this center point, that means the radius on the other side, which touches the circumference at the point B. So I can say AB as a diameter. And you know, right, OB is also radius. And what I'm saying here, AB is a diameter. So how can I define the relationship? D is equal to 2R. So what is the relation between the diameter and the radius? Twice the radius will give us a diameter. So in our question, if they are given diameter and you are supposed to find the radius, how you will find? Just divide the diameter by 2, will get the radius. So, and we have one more concept. What is that? Area and perimeter of a circle. So, generally for any shape, what is area? It's nothing but the inside part. This is what area. So, for circle, this is the area. And what is the formula for area of a circle? Which is pi r square. And what is the perimeter of a circle? In circle, we will say the perimeter are circumference. Generally, for any shape, what is perimeter? The border of that shape is nothing but the perimeter. So, over here, the circumference of a circle is 2 pi r. And still we are going to see about two more concepts. One is sector and segment. For that I'm taking another circle. And here for defining the sector, I need two radius. So the figure which is enclosed with two radius and one arc is known as sector. So this is what sector. And since this is the area is very less, so I can say this as a minor sector. But here we can have one more sector to see here. Same two radius and this arc is going to be little more longer. So I can say this as, so over here this is of major area, so I can say this as a major sector. So what is a sector? A closed figure which encloses two radius as well as one arc. This is nothing but the sector. Now we need to know what is segment also. So for that I will take one more circle. So I am drawing here one more circle. So what is segment? The chord and the arc. So it's going to get enclosed. So I'm marking one chord over here. You know what is chord, right? It's a line segment where the two endpoints are lying on the circumference of a circle. And this is nothing but the arc. So one chord and the chord, that means arc, are getting enclosed. They are known as segment. Over here also on the opposite side also we have same, right? So here one chord and here this is nothing but the arc, right? So here also this is also a segment, this is also a segment. Since the area is less, I can say this as a minor segment, and over here this is a major segment. And we need to know one more concept also, which is quadrant of a circle, because in some problem they will be saying the quadrant of the circle area you have to find like that. First we need to know what is quadrant, right? So you can have one circle, cut the circle into four equal parts, like just draw one graph. It's actually not looking equal, so four equal part. So I can do like this, yeah. So this is one part, this is two, this is three, and this is four. So each part is nothing but the quadrant of a circle. So what is the formula for finding the quadrant of a circle? So you know what the area of the circle as pi r square. So you are dividing this into how many group? That's nothing but how many part? It is 4. So quadrant of a circle area is pi r square by 4. If the question comes, find the area of the quadrant of a circle, then you can use this formula. Semicircle means it is by 2 because you are dividing the circle into two parts. So these are all the concept overviews. Now we are going to majorly concentrate on area of the sector, length of an arc and all. So we'll see that. The next one, how to find the area of the sector. So for that, first we need one circle, and you know what is sector, right? Two radius and one arc is nothing but the sector. So for this sector we are going to find the area. So what is the formula for finding the area of the sector? So I can first mark this O, A, B, and here it is C. So what are the radius? OA is one radius, OB is another radius, and what is the arc? ACB is an arc. So all these three are enclosed and making one closed figure, which is nothing but the sector. We are going to find the area of the sector. If they ask area of the minor sector, you are going to find this area. If the question is coming as find area of the major sector, then you have to find this area, right? So first we'll find the minor sector. How you will find the area of the sector? So there is one formula, area of a sector equal to theta by 360 into pi r square. So this is the formula for finding the area of the sector. So over here, what is this theta? So we know we have two radius, right? So these two radius are inclined at which angle? This is what the theta. Okay, so theta by 360 pi r square, and you would have given with radius. So replace the r value with the given radius, and theta is nothing but two radius, how much angle they are inclined. If it is minor sector, I have to check this theta. If it is major sector, theta is going to be what? This one, right? So this is how it will get differ. So for finding the area of the sector, this is the formula. Maybe they given this theta, and you are, maybe I can find the minor sector. I found it. Now you have to find the major sector. So how can you find the major sector easier? So first find what is pi r square. In that you just subtract the minor sector, you will get the major sector area. This is one more way to find the area of the sector. Next, we'll see how to find the length of an arc. Okay, so here I'm having two radius and this. So what is length of the arc? So first I will mark here O, A, B. So I want to find the arc length which is from A to B. So how to find this? We have a formula, theta by 360 into 2 pi r. So this will give you the value for length of an arc. So this is how we need to find the length of an arc. So we'll move to the next concept. The next concept under this chapter is how to find the area of the segment. Actually, you know what is segment, right? One chord. So I can mark this chord as A and B. And there is one more arc. The area enclosed by a chord and an arc is nothing but the segment. But we don't have any direct formula for finding the area of the segment. Actually, we have to find this area. But since we don't have the direct formula, we are going to use the sector area formula. So I'm just drawing the sector. So it's going to be the center O, and from OA, OB, that from O to A as well as B, I am making the radius. So we know what is a sector, right? The sector is nothing but two radius and one arc. The enclosed figure which having two radius and one arc. So over here I can say the sector as OA CB. So this is a sector, right? So this is how we are going to use. So first we'll find the area of sector OACB. So this full area we will get, but we want only till this, right? So what I'm going to do, we are going to find the area of this triangle, and if you cut it from this area of the sector, we'll get this area of segment. So what I'm going to do, subtract area of a triangle. So area of triangle OAB. So if you do this, we will get the area of the segment. Segment, what is a segment? Which is ACB. So always whenever you want to find the area of the segment, we need to first find area of the sector, and the triangle we need to subtract, then only we'll get this segment. And you know the formula for finding the area of the sector, right? Which is theta by 360 into pi r square, and area of the triangle generally we will use half into base into height, but you won't be having everything in directly. So in some problem I have explained this. I have attached certain problems over here. So just check that how to find the area of the triangle. Even we will use one more formula also, which is half into r square sine theta. So this is also one more formula for finding the area of the triangle. If you want more detail, please refer the problems of this chapter. And let Here I have given some sample problems to practice, which covers almost all type of problems. Totally 10 problems are there. Try to solve this and get the answer. If you want to verify the answer, I have already uploaded the solution for all these questions, and all the links are available in the description. Please check. If you have any other new question, please comment so that I can give the solution of those questions too. Hope you understood. Thank you.